Hello and welcome back to RC Model Reviews, and here I have the JROC G8. You've seen part one of the review of this. I can't do a part two until I can fly, so you'll have to wait for that. But this is the XG8. Now this is, as I said, there's a lot of things I like about this radio, but there's some things I'm not that fussed on. The sticks are a bit plasticky, but okay. In New Zealand, this is an almost $800 radio. And as an $800 radio, I have to say it doesn't compare well with some of the lower cost options like the Turnigy and the FrSky Tyrannus, not because it's an inferior radio, but because it's so much more expensive. And you know, it's all about value in the hobby. One of the things with these radios is, as I say, the cost. And a receiver like this, which is the, what is it? It's the RG813B receiver, comes with the XG8 with this little telemetry satellite here. Believe it or not, in New Zealand, these are $250 odd. I'm kidding you not. That's the price of one of these receivers. Unbelievably expensive, especially when you consider you can buy, you know, off-brand things like, well, not off-brand, but alternate brand systems like FrSky and even Futaba clone receivers for a tiny fraction of that price. So that's a point against the JR. Even if you love this radio to pieces, you're going to be pretty upset with the price of equipping your entire fleet of models with matching receivers, because it's DMSS. So it doesn't work with Spectrum, it doesn't work with FAST, it doesn't work with ACCST, it doesn't work with AFHSS, any of those other acronyms. It only works with DMSS receivers, and to date, haven't been a lot of those except the ones that JR themselves make, but that's changed. I was on Hobby King's website the other day and I spied a new alternative, and that's this. Look at it, it's like a giant spider web. This is the Redcon DM-9F, and this is a DMSS receiver, so it should work with the XG8. Now, I have to say, I wonder why they've got such long wires on the satellite. There's a few things to look at here, and I also wonder if it actually works, because it is a, you know, a clone, obviously, maybe not a clone, but it's a compatible, supposedly, receiver. So what I'm going to do first of all is rip the covers off and have a look and see how well it's made. Actually, just before I go that far, one thing I've noticed, it's disappointing, really. Look at that label. See that label? It's a square label in a round hole, because this actual plastic has a kind of a rounded corner under here. If I might push it down with this, and you might be able to see, but the corner itself has got a rounded edge like that, and they're pushing a square label into it, so it's never going to fit properly. I mean, that's tiny, that's small, it's nothing really, but you know, if you're gonna go out there and try and compete with JR, you might as well try and just pay a little bit of attention to the small details. Having that label printed so that it would actually fit in the moulding that's there would have been a nice start, and perhaps added a bit to your credibility as a off-brand option. But first of all, let's have a look at them side-by-side comparisons size-wise. Well, about the same length. Yeah, they're pretty much the same length. The clone receiver is a bit wider, as you can see. You know, it's a bit of extra width in that clone receiver, and it's also a bit deeper, the main body. Not by much, but it's a little bit deeper, and certainly a little bit wider. The satellites, by comparing those, let's look at the satellites. There's not a lot in it, really, is there? I think the clone one's a little bit narrower, but it is a fraction thicker, and lengthwise, well, they're pretty much identical. The difference is this doesn't have any wires dangling off it. This has got these huge, long cat's whisker 2.4 gig antennas, which in some cases may be a bit of a problem if you're trying to fit them in a small model. The lead that joins the two is pretty much identical in length. Not a problem. This is a twisted cable, this is a flat cable. Shouldn't make much difference. In theory, these pick up less noise than those, but I don't think it's going to be any problem at all. So let's get the covers off. Let's see what's inside these beasties. So here's the main receiver itself, and the construction looks quite reasonable. The soldering is good. There's 3 quad packs here. Can't read the writing on them, I don't think. Oh, the one I can do, this is the main receiver chip here. This is the one that does all the 2.4 good stuff, the Texas Instruments CC2520. Quite common, and an increasing number of the 2.4 gig systems on the market, which is why we've now got companies making multi-protocol receivers. One thing I'm not that impressed with is we've got the antenna here. This is one antenna, joins onto this little trace, travels all the way down here, and joins onto that one. So these antennas are actually in parallel. There's not actually diversity at all. It's not very good. That's just rubbish, actually, to be honest. Just 2 antennas in parallel. It's not the way you do diversity. It looks good from the outside, but from a technical perspective, no, that's not very good at all. yeah, this typical stuff you find on 2.4 gig stuff. You've got controlled impedance stuff here. No, there's probably a multi-layer board, and it's all done as per the manufacturer's application note. But this antenna stuff, no, that's not good. That's not good at all. I'm not happy with that. What else have we got? Yeah, not much to talk about. Some tantalums. I'll take the board out of that and see what's on the back side. I don't expect to find much on the back side of that board. And as I suspected, it's just the other side is bare. There's a few vias and some earths and a few traces, but nah, not really anything to get at all excited about. And here's that little satellite receiver. It's again just got a Texas Instrument 2.4 chip and a quad pack, which probably does a bit of processing. And once again, those antennas, they're just wired in parallel. Why bother? If you're going to do that, you might as well just use one antenna. There's no advantage to having two antennas wired in parallel like that. No advantage at all. In fact, there are some significant disadvantages. But hey, it looks good, doesn't it? Yes, it looks very good. So following the instructions that came with the receivers, very simple. I have bound the receiver to the XR8 or XG8, sorry, and that seems to have done the trick. So I will now go and do a little range test, comparing it to the original, the genuine branded JR receiver. See if it should give the same range, the same basic elements should produce the same results. The difference would be when you were flying it, especially with those antennas which aren't really diversity at all, but we'll have a look at it. Okay, something I almost forgot to do, and that's check how low a voltage these receivers will run on. Currently we're at 4.99 volts, let's say 5. There's not much really to split hairs over. Let's bring the voltage down. It says it'll run down to 4 volts, but it should run much lower than that. Let's see how we go. The blue lights will go out when the receiver stops working. So that's the specified minimum voltage. Most of these receivers today will go right down to 3 volts or so. So yeah, it's still going 3.4. Let's see what happens. Yeah, I don't think there'll be any brown at, oh, there we go. It stopped at about 2.9. Interestingly enough, there's a blue light still on in the main receiver. Let's bring it up and see. There we go. It's back on now. So about 3 volts. Works down to 3 volts. That's just fine and dandy. No problems there at all. So here is the genuine JR receiver. Let's wind that voltage down and see how it performs. Currently we've got a solid LED there. And take it down 4 volts. There we go, still falling. Oh, there we go, down to 3.2, 3.1. And the lid's getting dim, but it's still on. 2.8, 2.7, 2.6. Wow, that light's gone out. There we go. About 2.7 volts seems to be the threshold for the genuine JR receiver. That's quite a bit lower actually than the other one, the Redcon. So yeah, JR certainly seems to outperform the Redcon in terms of its low voltage. Now one thing I did notice that I wasn't very impressed with this particular setup is, now I've turned the receiver on. You can see it's not bound because the lights are flashing. I'll turn on the transmitter and there we go, the transmitter is now on. Well, why isn't it linked? Still not linked. It seems that with this receiver, if you turn on the receiver before the transmitter, it just simply will never link up, which is rather disappointing because most other systems like the FreeSky, it will link. Doesn't matter which you turn on first, it will link up. In this case, it doesn't. I don't know why that is. Maybe it's just to stop it, a safety issue perhaps, so stop your motor starting up at full speed, but yeah, I'm not sure. Okay, so I've powered up the receiver now, but the lights don't flash if you turn the receiver on first. It's just completely dim. I'm going to turn on the transmitter and see if it will actually link up. There it does, it links up. So the Redcon receiver will not link up if you turn it on before the transmitter, but in the case of the JR, it links up almost straight away. That's something to watch out for with the Redcon. If you turn the receiver on first, then you're not going to get a link with the transmitter. Okay, now I'm going to try a test where currently it's all linked up, it's all working fine. I'm going to turn off the transmitter, and then I'm going to turn it on again to see what would happen if the transmitter signal was interrupted for any reason while you're flying. So let's turn that off. And as you can see, the LEDs are now flashing, indicating that there is no link. Turn the transmitter back on. And there we go. That was a pretty quick link up. I was quite happy with that. Let's just try it again, just in case there's any problem that doesn't occur the first time. So there we go again. We've got, notice these lights flickering quite intermittently. Turn it back on. And yep, that seems to be okay. So the relink time's pretty good. That's not too bad. That's not a problem. So now we have the genuine JR receiver linked up to the 8-channel transmitter. I'll turn off the transmitter and we'll see the lights should start flashing, or they just go out, I think, on this. Oh, no, there we go. We've got some flashing going on, no problem. Let's turn it on and see what the relink time is like. Yeah, it's about the same. Not much to choose between them. They link up again pretty quickly. That's pretty good. So, excuse me for being all hot and sweaty. It is summer and I've just gone and walked a long way to range test these little receivers. Now, with the genuine JR receiver, I was able to get 72 paces before I started getting any flickering, any noticeable flickering on the LEDs indicating that the signal was getting weak. Packets of data were being lost. 72 paces, and up until that point it was rock solid. There was no loss of packets. It was just totally solid. What I'd expect. With the other receiver though, what's it called? The Redcon, I was getting quite noticeable flickering within 20 paces of walking away from the transmitter. Obviously, as I suspected, these antennas, no diversity at all, so packets were being lost all over the place. It wasn't really 100% reliable link. I was actually surprised how bad it was, I'm afraid. And then when I got to 50 paces, it was just all over. There was no more. So this has got less range. I would have expected it to have about the same, but it is less range, 50 paces versus about 72 paces for the genuine JR. Now, this is a $30-something receiver, but trust me, it seems on the basis of what I've done at the moment, my tests I've done, it is a $30 receiver. It's not a genuine JR. It doesn't give the same levels of robustness. The design is more for looks than for function in terms of that antenna stuff. If you're going to have just, why even bother having these long whiskers if they're just wide and parallel? It's silly. It's a waste of time. Now, I'd like to give some more testing on this. I'd like to put it in a model and fly it around, but we all know why I can't do that. To see what happens, but suffice to say, based on my testing to date, I would not commit this receiver to an expensive, fast or heavy model because I wouldn't feel confident with those massive packet losses and this total lack of receiver antenna or antenna diversity. Having said that, of course, there are two receivers, so there are effectively two antennas. I would almost be tempted just to chop one of those antennas off on each receiver because the other one's only going to get in the damn way. It's only going to reduce the signal. It's not going to enhance it at all. I might do some tests on that. We might actually just set up a little rig sometime, test this out, measure the packet loss, and see what happens if we take one antenna off. Personally, I think it'll work a whole lot better. Who knows? But there you go. That's the Redcon DM-9F receiver. My preliminary tests on this thing. There we go. More calls. My preliminary tests on this thing, and yeah, I personally don't think it's actually even worth the price being asked. But I have got one, so when I can, I will fly it in something very cheap and light, if I can fit it in. Thank you for watching. If you've got any questions, please put them on the bottom of this video. If you've got any comments, do the same. Stay tuned. There's more videos coming. In the meantime, of course, it's back to the bench.